Good day, all of you. Last time we've talked about measurements. In this class, we're gonna solve past paper questions regarding the measurements that we had last time. If you haven't watched the video, please go back and watch it, and return to past paper questions. Without further ado, let's dive right into it. Question 1. The diagram shows an enlarged drawing of the end of a meter rule. It's being used to measure the length of a small feather. What is the length of the feather? Alright, first, the feather is not starting from the zero. We haven't started the measurement from the zero, so I will take first reading 1, which is this one. Reading 1, starting from this and end up with this, right? So I'll take the first reading 1. This on top, it's given in millimeter, and at the bottom, it's given in centimeter. All right, reading 1 is 10 millimeter. That's reading 1. Reading 2 is 29 millimeter. The actual reading is reading 2 minus reading 1, which is equal to 29 minus 10, and that's equal to 19 millimeter, right? So the length of the feather is 19 millimeter, which is number A. Question number 2. A student wishes to find the volume of a small regularly shaped stone. A ruler and a measuring cylinder containing some water are available. Which apparatus is needed? There is a measuring cylinder and a ruler. Which apparatus are needed to measure the volume of the stone? In measuring the volume, we don't need the length. Neither number A says neither the ruler nor the measuring cylinder. Of course, we need one of them, so this one is wrong. The measuring cylinder only, the ruler and the measuring cylinder, the ruler only. We don't need the ruler, so it's gonna be number B, which is the measuring cylinder only. We place it inside the measuring cylinder and we see the volume before we immerse it and the volume after. We find the difference between them, which is gives the volume of the rock or the stone. Question 3. The diagram shows a ball hanging on a string. The ball swings from point W, from this point, to Z and returns back to W. All right. Which statement about the ball is correct? Which statement about the ball is correct? The kinetic energy of the ball is greatest at point P. First, let's review what's potential energy, where is the highest potential energy and where is the highest kinetic energy. Potential energy depends on gravity, right? So the higher the object, the more potential energy it has. Kinetic energy, it depends on movement. So the faster the object, more kinetic energy, and more gravity, there is more potential energy. At this part, at W, it is the highest point, so it has more potential energy but less kinetic energy. Now, it says the kinetic energy of the ball is greatest at point W. That's wrong, because it's high, so its potential, it has the greatest potential energy. The kinetic energy of the ball is greatest at point X. It is not the fastest point. The kinetic energy of the ball is greatest at point Y. In the middle here, the ball is at fastest point. So question part C is the correct one. The kinetic energy of the ball is greatest at point Y. Why are we saying this? Because it's the point at which the ball is at its fastest speed. Moving on, question 4. A measuring cylinder is used to measure the volume of a quantity of water. A measuring cylinder is used to measure the volume of a quantity of water. Which measuring technique would not? Please be careful when words are in bold. You have to be careful for that, for those words. Improve the accuracy of the measurements. Would not improve. Making sure that the measuring cylinder is vertical. This is one of the ways that we're making sure that the measurement is accurate. So this is not the one we're looking for. Make sure that the water surface is at eye level. This also improves the accuracy, which we're not looking for. Reading the top of the water meniscus. Remember, we said in order to be accurate, we need to read the bottom of the meniscus. And here it says the top of the meniscus. So this is not improving the accuracy. Using the smallest measuring cylinder, this also improves the accuracy. So my answer that I'm looking for, it's reading the top of the water meniscus. Excellent. Moving on, question 5. The diagram shows 4 identical spheres placed between 2 wooden blocks on a ruler. 4 identical spheres. Identical means the same. They are exactly the same. What is the diameter of one sphere? We're looking for the diameter of one sphere. First, we need to find the diameter for 4 of them, which is this reading minus this reading. Reading 1, 1, 2, 3, 4 is 4 what? Centimeter. How do I know it's centimeter? From the ruler here it says 4 centimeters. So reading 1 is equal to 4 centimeter. Reading 2 is equal to 10, 11, 12 centimeter. Now the actual reading is R is equal to R2 minus R1. R is equal to 12 minus 4, which is equal to 8 centimeter. Right? If the 4 of them makes 8 centimeter, how would I find the diameter of one of them? So 8 centimeter divided by 4 of them, which is equal to 2 centimeter. That means the diameter of one sphere is number B, 2 centimeters. Very good. Question 6. A cook wants to prepare some food to be cooked by 1:15. At 1:15 he wants the food to be ready. He uses an oven with an automatic timer that can be set to switch on and off at certain times. The oven needs to be switched on for 2 hours and 10 minutes. At which time does the oven need to switch on? So the time that he wants the food to be ready at 1:15 p.m. and that time minus 2 hours and 10 minutes, how much do I get? 15 minus 10 is 5, right? And 1 minus 2, 1 is actually 13 because it's p.m. 13 minus 2 is 11, isn't it? So it should start at 11 and 5 a.m. Excellent. The diagram shows a measuring instrument. This is a measuring instrument. Which quantity is this instrument used to measure it? Of course, this is a measuring cylinder, isn't it? Measuring cylinder is used for measuring volume without any waste of time. Which option contains only apparatus that could be used to determine the volume of a small block of unknown material? Measuring cylinder, meter rule, measuring cylinder and stopwatch, meter rule balance, meter rule and stopwatch. We do not need the stopwatch. We do not need the balance nor the ruler. We do not need the meter ruler and a stopwatch on their own. We need measuring cylinder and a meter ruler, which is number A. Moving on, the diagram number 9. The diagram shows a measuring cylinder used to measure the volume of a small stone. What is the volume of the stone? Before we add, that's reading 1. Before we add it, it was 10, 12, 14, 16, 18. Reading 1 is 18. 18 what? It's given here, 18 centimeter cube. After we add the stone, 22, 24, 26. reading 2 was 26 centimeter cubed. The actual reading is R2 minus R1, which is equal to 26 minus 18, and that's equal to 8 centimeter cubed. 8 centimeter cubed. So our answer is number A, 8 centimeter cubed. Question 10. A student uses a measuring cylinder to measure the volume of a quantity of water. Which action would make her result less accurate? Making sure her eyes is level with the water surface, that makes it more accurate. So this is not the one we're looking for. Making sure the cylinder is vertical, this also improves accuracy, we don't want it. Reading the bottom of the meniscus, this also improves accuracy. Using the largest measuring cylinder possible, this is the one we're looking for, it doesn't make it accurate. Number D. Moving on to the next question. A student uses a measuring cylinder to measure the volume of some water. The diagram shows part of the measuring cylinder. The top and the bottom of the meniscus are labeled. This is the bottom of the meniscus and this is the top of the meniscus. What is the volume of the water? Of course, when we're reading, we read the bottom of the meniscus, which is at this level. Right? Someone would say 41, 42, 43, 44, or 46, 47, 48, 49, which is not correct. This is the distance from 40 to 45. 41, 42, 43, 44, 45. So each small line makes half, right? So this is 45.5, 45, 6, 46.5, 47. So the reading is 40, 47. Be careful with the marks. Number 12, a student wishes to measure accurately the volume of approximately 40 centimeter cubed of water. She has two measuring cylinders, a larger one that can hold 100 centimeter. It has 40 centimeter cubed, and she has one that can hold for 100 centimeter and a smaller one that can hold for 50 centimeter cubed. The water forms a meniscus where it touches the glass. This is the top of the meniscus of both of them, and this is the bottom of the meniscus. Which cylinder should the student use, and which water level should she use to ensure accurate result? She needs accurate result. We said you should use all the time to make it more accurate. You should use the smallest measuring cylinder that can hold the whole water. The whole water is 40 centimeter, which can be held in 100 centimeter cubed and 50 centimeter cubed. But which one is the smallest? Is 50 centimeter cubed. It would be more accurate to measure that one. So, and what should I read? The top of the meniscus or the bottom of the meniscus? Of course, the bottom of the meniscus. So my answer is going to be using a smaller cylinder and the bottom of the meniscus, which is number C. Very good. Now, moving on to the next question. The diagram shows part of a ruler. The ruler is used to find the length of a nail. What is the length of the nail? The length of the nail is not starting from 0. So we've got two readings, reading 1 and reading 2. That's reading 1 and that's reading 2. I take reading 1, reading 2, find the difference between them, and that's your answer. So this is 1 centimeter. Reading 1 is equal to 1 centimeter. Reading 2 is equal to 2.5, 3, 3.5, 3.6, 3.7. That's 3.7 centimeter, isn't it? 3.7. Then the actual reading is equal to R2 minus R1, which is equal to 3.7 minus 1, and that's equal to 2.7 centimeter cube. So my answer is number B, 2.7 centimeter cube. Which instrument is used to compare the masses of two objects? Balance is to measure the masses, but to compare we use a manometer. 15. Number 15, diagram 1 shows a measuring cylinder containing water. 5 identical, please be careful, identical steel balls are now lowered into measuring cylinder. Diagram 2 shows the new water level of the cylinder. This is before we add the balls, and this is after we add the balls. But be careful, when we add the 5 of them, this is what happened to the water. So the actual increase of water is for the 5 of them. In order to get one of them, it says what is the volume of each steel ball. In order to get one of them, we need to divide by 5. Before it was 40, and after it was 70, right? So the actual reading is equal to 70 minus 40. The actual volume for the 5 of them is equal to 70 minus 40, which is equal to 30 centimeter cube. This is for the 5 of them. If we want the volume of one steel ball, so of course we would divide 30 divided by 5, which is equal to 6 centimeter cubed. And this is my answer, number A, 6 centimeter cubed. A stopwatch is used to time a runner in a race. The diagram shows the stopwatch at the start and at the end of a lap of the race. How long did the runner take to finish the lap of the race? It starts at 50 seconds and 10 parts of the seconds, and it finishes at 1 minute and 40 seconds. 1 minute and 40 seconds, 1 minute is 60. 60 plus 40 is equal to 100, right? That's 100 seconds. And it starts at 50, so 100 minus 50 is equal to 50, right? So it takes how much? 50 seconds. Question 17. The diagram shows the readings on a measuring cylinder before and after a small metal cube is added. How many more identical cubes can be added to the cylinder without causing the water to overflow? Do not include the cube already in the cylinder. There is a cube here in the cylinder. Let's find out how much is it. It was 3, and then it becomes water. After we added the cube, it becomes 5. 5 minus 3 is equal to 2 centimeter cube. We want to add more cubes so that the water doesn't overflow. How much can we add? How many cubes can we add? If we add the first one, it becomes 7. If we add the second one, it becomes 9. Can we add another one? It will overflow. So how many should we add? We should add just 2 of them. Next, a student measures the length of a rod XY by holding it next to a meter rule. The student writes down the length as 94.8 centimeter. 94.8 centimeter. Which statement is correct? The value is correct. The value is incorrect because it should be 95.2. The value is incorrect because it should be in millimeters. The value is incorrect because the student should subtract the reading for and y from the reading for x. Of course, this is the first reading and this is the second reading, so my answer should be number B. The student should subtract this from the actual value to get rid. Alright, a student uses a ruler to measure the length and the width of a small rectangular metal plate. What is the area of the plate? Very good. What is the area? The area is equal to length times width, right? This is actually two questions in one question. All right, first we need to measure the length, and then we need to measure the width, and then multiply them by each other to get what? To get the area. Length, this is before 0, by 2, right? So let's start from here. That's R2 and that's R1. R1 is negative 0.8. Let's say negative 0.8. Or we can, from here to here, that's 1, 2, right? 3, 4, 4.1, 4.2. So the length is 4.2. L is equal to 4.2. Width, start from here. 1 here, 2, 3, 3.5. And the width is equal to 3.5. Let's multiply those to get answer. 4.2 times 3.5, that's equal to 14.7, which is number B. A cyclist, question 20, a cyclist rides round the track 3 times. Her friend uses a stopwatch to record the time at the start of the ride, after 1 circuit, and at the end of the 3 circuits. The readings from the stopwatch are shown. This is at the start, it was 6. After 1 circuit, it becomes 180. And at the end of the 3 circuits is 600 seconds. What is the average time for 1 circuit of the track? The average time, of course, is the whole time divided by the number of rounds. So it's 600 minus 6, that's equal to, because at the start it was 6, right? 600 minus 6, that's 594, divided by 3 is equal to 594 divided by 3, that's equal to 198 seconds. A cylindrical can is rolled along the ruler shown in the diagram. At the start, the can rolls over twice. What is the circumference distance all around the can? Alright, it starts from here. The circumference is the space all around it, right? So when it completes one rotation, that's the circumference. That's 2 and that's 15. So 15 minus 2 is equal to 13 centimeter. 13 centimeter. Alright, question 22. Drops of water are dripping steadily from a tap or faucet. The diagram shows a measuring cylinder which has collected 120 drops of water. How many drops in total will have been collected when the measuring cylinder reads 10? 120, they make 4 centimeter cubed. 120 of them make 4 of them. So if we add another 120, this becomes 8. In order to make it 10, we need to add another 60, 100 and 180. So the total is 100 and 180. A ruler is used, question 23, a ruler is used to measure the length of an object. What is the length of an object? 2.5, that's reading 1. 3, 4, 5, 6, 6.5. Reading 1 is 2.5 and reading 2 is 6.5. 6.5 minus 2.5, that's equal to 4 centimeter, is equal to 4 centimeter, right? The diagram of a copper wire is thought to be approximately 0.3 millimeter. Which instrument should be used to obtain a more accurate measurement of the diameter of the wire? The diameter of the wire is very small length, very short. We cannot use a measuring tape. We cannot use a meter ruler, but we can use a micrometer for small lengths like this. Which instrument can be made using a micrometer screw gauge? The air pressure of a tire, that's wrong. The diameter of a wire, that's correct. the turning effect of a spanner, the wavelengths of a microwaves. We can use it for measuring the diameter of a wire. Thank you all for watching. This would be all about measurements and question related to measurements. If you've got any question, please write them down in the comments below.